Now that we know the meaning of a binomial random variable, let's determine how to calculate its probability. In the 2018-2019 NBA season, Kevin Durant made 41.6% of his three-point shots. If Kevin Durant took 5 three-point shots in a game, find the probability that he made exactly 2 of them. This problem contains a binomial random variable. The set number of shot attempts is 5. He took 5 three-point shots. In each shot attempt, Kevin Durant either makes the shot or misses it, i.e. success or failure. The shots are independent of each other, and the probability of him making the shot is a constant 41.6%. If Kevin Durant makes 41.6% of his three-point shots, then he misses 58.4% of his three-point shots. These values can be written as the probability of success is 0.416 and the probability of failure is 0.584. To figure out the probability that he makes exactly 2 of the 5 three-point shots, we need to determine the different ways that Kevin Durant could make 2 three-point shots in 5 attempts and calculate the probability for each of these different ways. Let's determine the different ways that Kevin Durant could make 2 three-point shots in 5 attempts. For example, he could make his first 2 three-point shots and miss the rest of them. That would map out as success, success, failure, failure, failure. What's the probability that this event will happen? Well, we just multiply all the probabilities together and we get 0.416 squared times 0.584 cubed. Is this the only way that Kevin Durant could make 2 three-point shots in 5 attempts? No, there are other ways in which he could do so. It could also be failure, success, failure, success, failure. What's the probability that this will happen? Well, it's the same, 0.416 squared times 0.584 cubed. These values are the same. Since multiplication is commutative, no matter the order in which the shots are made, the probability will always be the same. To find the exact probability of Kevin Durant making 2 three-point shots out of 5, we need to take into account the number of ways that he can make these shots. How many ways can he take 5 shots and make any 2 of them? This problem models a combination, since repetition is not allowed, i.e. cannot take a shot back, and the order in which the shots are made does not matter. Recall that to find the number of different combinations of n objects taken r at a time is n factorial over n minus r factorial times r factorial. So the number of ways that Kevin Durant can make 2 out of 5 shots is 5 factorial over 5 minus 2 factorial times 2 factorial, which is 10. So there are 10 ways in which Kevin Durant can make 2 out of 5 three-point shots. The probability for each of these ways is 0.416 squared times 0.584 cubed. Therefore, the probability that Kevin Durant made exactly 2 out of the 5 three-point shots is 10 times 0.416 squared times 0.584 cubed, which is 0.345 or 34.5%. Let's try to generalize this formula using the variables n, k, and p, where n is the number of attempts, k is the number of successful attempts, and p is the probability of each successful attempt. The probability of exactly k successful attempts in n attempts is the number of combinations times p to the k times 1 minus p to the n minus k power. In math class, Mike is taking a multiple choice quiz. There are 10 questions. Each question has 4 possible answers. He did not study for the quiz. What is the probability that Mike earns a 70% on the quiz if he guesses an answer to each question? Out of 10 questions, Mike needs to get 7 of them correct, so n equals 10 and k equals 7. The probability of Mike getting each question correct is 25%, or 0.25, and that's going to equal p. Therefore, the probability that Mike earns a 70% on the quiz is, we plug in all of the information we have, and we get 0.3%.